So here today we'll talk more object-oriented programming, and so on Monday we covered object-oriented programming, the S3 system with generic functions and methods, and the key there was that methods belong to generic functions. And S4 is another system, and it's very similar in that you have methods belonging to generics, except S4 adds formality and rigor in that in the S3 system we saw it was very easy to just create a new class. We just say class, and then we give it a list object or just whatever object, and we're just going to say class is equal to foo, okay? And all that did was create in the attributes, say this class is class foo. And then if we wanted to change that and say this is going to be a class data frame, we could do that. And R, it was fine. R didn't complain. Maybe if we tried to run a function where the class was misidentified, the function or the method would give us some errors or not behave the way we wanted to, but there was no problem there. With S4, we have to formally define the classes and create these create new instances of the class using the method new. And so we can't just on the fly decide to change classes, otherwise it's going to give us errors and whatnot. Okay, so here it says classes have formal definitions which will describe their fields and inheritance structures. Okay, and then another difference is that method dispatch can be based on multiple arguments, not just one. So with S3, it was which method it used was always based on the class of the object, right? It just looked at the class and it says, okay, this is the method I need to use. With S4, we can actually say look at the class and some other attribute. We're not going to worry too much about it. We also have the at operator for extracting slots or fields from an S4 object. Students always ask, do I need to know this for the test? So I'll tell you this, and that is I will not put S4 stuff on the midterm exam. You will be responsible for knowing S3 for the exam, but not S4. Okay, but please at least still pay attention to what we're talking about. Okay, and then we'll talk about reference classes later on today, and reference classes will make an appearance on a future homework assignment, but I will not ask you test questions regarding a reference class objects. Okay, so as far as tests go, you don't have to worry about today's stuff, but you will want to know reference class stuff for a future homework assignment, I believe. Okay, all of the S4 stuff is in the methods package. This package is always available when you're running R interactively, but R does have a batch mode. Okay, batch mode is you run the scripts kind of from the command line, and it executes without loading up the graphic user interface. We have a question. Yes.
Are you going to post this lecture?
Yes, I will. Oh, you mean the code, the markdown file? Sure. Give me a second. Let me. Okay. So if you are gonna use any kind of S4 stuff in a script, it's a good idea to load up library methods, just because this library may not get loaded in batch mode in R. It's also worth noting that all of the objects in the base packages in R are S3. Okay, so as far as S4 goes, we have to kind of create stuff here. Oh, I guess I said that right here. So you can tell if something's S4, you use the structure command, and it will say it's of class formal, or you can use the command is S4, the function is S4, and that will say yes, it's true. Or if you use prior, the object type is going to be S4. Yeah, again, no S4 classes in the commonly used base packages. So here, we can load up library stats4, and that contains the function MLE. Okay? And so as far as MLE goes, the output, we're going to store the output of MLE. So the MLE object is an S4 object. So we can ask, is S4 on this MLE, this fit thing that we've created? It will say true. If we ask, what's the object type of fit? It says S4. And then as far as the functions go, okay, there's a function called nobs, okay, number of observations. This is a generic function, okay? It is an S4 generic. So if we say, is it S4? It will say true. And we ask, what's the function type? Function type is generic. Over here, if we want to know, okay, what is the method of this nObservations function that is specific for MLE type objects, okay? So here we run the function nobs on the object fit. Fit is an MLE object, so this is going to find the function or the method specific for fit type objects, okay? So we say method from this call, and we're going to just say whatever that method was, it's we're going to put that into MLE nobs, number of observations. And so this is an S4 function, and if we ask what's the function type, it's a method. Okay, does that kind of make sense? And then we can ask if an object is of a certain class using the function is. So what is the class of fit? It's going to say MLE, and we can ask, is fit an MLE object? Okay, MLE class object, by giving it two arguments, and that returns true. Okay. If we want to define our own classes and create objects with S4, we have to do it more formally. Okay, with S3 it was just very on the fly. We just say this list object, we're now calling it class foo. Okay, over here we have to use the function set class, and we create new instance of it using the method new. Okay, so it's kind of like we have just more paperwork to kind of make sure everything fits the proper structure. Okay, to kind of do things this way. All right, and you can always look up some documentation, looking kind of like for documentation for a class with special syntax. You say class ? Class name or something. For example, for the class MLE, we can find stuff like that. Okay, so when you define an S4 class, there are three things you need. You need the name, the slots, and if it contains anything. Okay, the name is just the name of the class. So if we're creating a class MLE, the name is just MLE, okay, or whatever it might be. We just create the name that way. If that object that we're creating, this class of object, contains values, those values are stored in fields, or we call these things slots. Okay, so generally we provide a list of the different slots or fields that it will contain. Okay, and then we have to specify what kind of values are allowed for that slot. So here we would say we're going to create a person class, and the person will be defined by the person's name and their age. So we'll say every person needs to have a name and an age. And as far as name goes, the name has to be character data. And as far as the age goes, the age has to be numeric data. Okay? And if you want to allow for anything, you can use any. If the object will inherit from something else, you can say it contains. It contains, and this kind of says it inherits from another class. All right, so here we will define a class called person, a class of an object called person. And that goes right here. We say set class person. And then the person will have two fields, or two slots, the name and the age. So we say, as far as the person goes, the slots is this list. The list is going to be name, which contains character data, and an age, which contains numeric data. And there we go. We've defined a person. Here we can define another class called employee. Employee is pretty much the same as a person, so we're going to say it contains person, okay? Meaning whatever defines a person, that is also something that employees have, okay? So employees are people, and so we say this object will contain everything that a person has, okay? But in addition, an employee has a boss, okay? And so we will say, as far as the slots go, we're going to give it a slot called boss, okay? And what does the boss, what kind of object has to be a boss? The boss has to be a person, okay? So it's not just a name, but it's actually another object of class person. Okay. All right. So we have to define our classes this way, in this formal setup. And then if we want to create a new instance of this, we would say we're going to create Alice. Okay, Alice is a new object of class person. Alice is a person. The name is Alice, and the age is 40. Okay, and so that's what we have here. John is a new instance of class employee. John's name is John. John's age is 20. Okay, and as far as the boss goes, we have to give it an object of class person, and so we're going to give it the object Alice. Okay, and so Alice here will contain the name and age over here. Okay, we can't just say, we can't give it a character name of Alice or something like that. It has to be an object of class Alice, so that a class person. So that's what we have here. Okay, so if you want to then extract the values stored within one of the slots, we use the @ sign. Okay, so we're kind of used to using $signs for these things. With S4 objects, we use the @ sign. Okay, so we'd say, okay, what is the age of Alice? We would say Alice @ age, and it's going to say 40. Okay, over here, if we ask what is in the slot for boss of object John, okay, so we can, this is pretty much doing John @ boss. It's going to return back, and it's going to be an object of class person, and this is what we have. Okay, slot is a name and slot is age or something like that. Okay, so here, so we can do this. Okay, and that's what we have. If we, if we go back, because of S4's formality, if we went back and we modified this, and I'm going to have to kind of add this into, I think, our final version of the slides. If I go back and I modify either the definition, if I modify the definition of a person, and I say a person actually has the name, an age, and a location, or something like that. If I modify the what defines a person, and I didn't update what Alice, this Alice object, and Alice only contains a name and an age, okay, then Alice no longer fits the way the object person is defined. And so that's going to create an error. If I ever try to use Alice as she's written here, after I've redefined what it means to be a person, okay, then this is going to cause an error in R, okay? So because of S4's formality here. Whereas with S3, we could do all these kinds of changes on the fly, and R just tried to do its best. With S4, we have formalities, and if things don't match up, it kicks back errors. Okay, let's talk about functions and methods. right? So again, in just like in S3, we have generic functions, and when we give a generic function an object of a certain class, it's going to look up and see if it has a method specific to that class, right? And if it does, it's going to run that method, and if not, it's going to run kind of the default here. So here there's a function already in R called union, and union works for vectors. But here we can say, you know what, I want to change union to be a generic function. And with S4, all we have to do is we do set generic on union, and it does that, okay? And then we're losing the text here. Okay, so here I would say, you know, set generic on union, and it does that. And then if I want a specific method, I would do set method for union, and then I give it kind of the classes of objects that it will accept. So now we're creating a method of union that will work for data frames. Okay, and then after we say this is what this is when you would use the method union is when you get data frame and data frame for x and y, then the way you would run this function is you have to do this, where you kind of bind these two together and do return what's unique. But this is now the function that it will run rather than the regular old union function. Okay, so union is now a standard generic, okay, standard generic here, and then we could say, and now we'll have kind of a specific case for union, okay? If I remove union, then union here, this is the original union function in base, okay? But if as soon as I do set generic to union, okay, so this is for vectors, but if I do if I change it this way, now union is it will say standard generic. Okay, so standard generic is kind of the equivalent of use method in S3. For S4, we call it standard generic, but in S3 it was use method. So when you looked up functions like mean in base R, it would say that says use method there. Okay, if we wanted to create our own generic function, we would do set generic, and we would do standard generic. Okay, so standard generic is the equivalent to use method. So again, we have like the generic function mean, which is use method, and then we have kind of our version. This is the code that of mean that will run the method that runs here. So we have something like that, but for S4. Okay, is that all right? Okay, let's talk reference classes. So reference classes are very different from S3 and S4. In S3 and S4, the methods belonged to generic functions. With reference classes, we have what we call message passing is a message passing object-oriented system, and therefore the methods belong to the objects themselves. Okay, so if you want to think of S3 and S4, you kind of have these generic verbs. So for example, you have the verb swing, and depending on the object I give you, and I say swing, what you would do would be different, right? If you if I give you a baseball bat and I say swing, you would put it up like this and you would swing, right? If I give you a golf club and I say swing, then you would, you would take it this way, and then you would swing as if it were a golf club. And if I give you something else, like a book, and I say swing, then you would look at this and you'd be like, what? And you'd probably do something a little bit awkward, but you'd figure it out, right? So, and that's kind of how S3 works. You have, you know, if you give it you would have a swing.baseball bat, swing.golf club, and swing.default, right? And depending on what you give it, you would execute the appropriate action, right? And we could, if I gave you a golf club and I say swing it like a baseball bat, you could swing the golf club like a baseball bat. You could force it that way. With message passing object-oriented systems or reference classes, this works kind of the way like Java or Python does. You have objects, and objects will have methods that they can do. Okay, so the objects define what actions are allowed. So you might have a phone object, and the phone object would have methods like turn on, turn off, make a phone call, I don't know, do something, right? You might have a flashlight object, and the flashlight object would have methods turn on, turn off, change batteries, point, I don't know, what else can you do with a flashlight or something, right? Maybe throw, or something. And so you would have each object is allowed certain actions, and those are the methods. And if you try to do something that's not defined, so if you don't have, so the flashlight will not have a stab method or something like that. You can't use a flashlight to then try to stab something. But with the S3 system, you would if I gave you a flashlight and I said stab, you would try to do your best to stab something with the flashlight, and it would be awkward, but maybe you could pull it off. With this setup, you're only allowed to do the methods that are defined in that object. Okay, and so here we have methods belonging to objects, not functions. The other big difference with reference class objects is that they are mutable, meaning that we do not have the copy on modify semantics of R. What does that mean? Normally in R, let's say you have something x. X is, let's say, the vector 1 through 5. And then I say y is equal to x. Okay? When you say y is equal to x, what R normally does is it takes x and it creates a copy of that, and y is now also the vector 1 through 5. And then if you change x and you say x is now 1 through 6, y is going to remain 1 through 5. That's how R works. Okay? You have x, when you say y is equal to x, R creates a copy of that thing, and those things are now separate and they don't interact with each other. With reference classes, when you say y is equal to x and x is a reference class object, y is just a pointer back to x. It's not a copy of x. It's a reference back to x, and so that's going to be different. One way to help us think about this is that reference classes are basically environments. Okay, when we have a reference class object, it's basically its own little environment with its own values and its own functions defined inside that environment. Okay, so they're actually implemented using S4 code as an environment. Okay, let's play with this and see if we can make sense of this. So we use reference class objects to define what we call stateful objects, objects that might change over time or something like that. Okay, and so we'll use a bank account example. Okay, and we define new reference classes using set reference class. Okay, so instead of using set class for S4, we use set reference class for reference class objects. And then the only thing you need is to give it a name, right? But of course, to be useful, we'll need to have fields and methods and stuff like that. But here we're just going to say, okay, here we're going to do set reference class account. We're going to call this account. And then when we say account $new, this is a method new, it's going to create a new object of class account. Okay, and that's all we need to do. But of course, if we want it useful, we would want something like a field. Okay, so instead of a slot, we call them fields when they're in reference classes. And so we're going to say, okay, you know what? We're going to create a reference class called account, And the one thing that the account contains is a balance. Okay, so the balance is going to be a numeric value. And so we say fields is equal to the list balance numeric. And so now I'm going to create a new instance of account using account $new, and I'm going to say balance is equal to 100. To access the field, we use $ rather than the @. So this is kind of probably something more we're accustomed to. So we say a $balance is 100. So A is a new instance of the reference class account and with a balance of 100. And if I say, what is the balance in A $balance is 100. Okay. Then I can change that just like other objects. I say a $balance. We're going to throw in the value 200, and we get the balance in A is 200. So far, so good? Okay. This is where things behave differently now that we're reference class objects. Okay. So here I'm going to say B is equal to A. B is equal to A. And I ask, okay, what is the balance in B? Balance in B is 200 because that makes sense, right? We changed the balance in A to be 200, and we said B is equal to A. The balance in B is 200. Now this part is different from what R normally does. Here I say I'm changing the balance in A to 0. And if I ask what is the balance in B, the balance in B has also changed to 0. Okay, because B is a reference to A. B is not its own thing. Normally when we do this, R creates a copy, but that's no longer the case. We have a reference. So B is a reference to A. So B $balance gets changed when we change the balance in A. Is that okay? So that's different, right? So if we want to have the kind of the copy semantics, we would have to do a $copy. So we leave off with, we updated the balance in A to 0. And if I'm going to create a new account D, we're going to say D is a copy of A. All right? We ask, what's the balance in D? The balance in D is 0. Then I update the balance in A to 100. When I update the balance in A to 100, then the balance in A is 100. And if I say, what's the balance in D? This remains 0 because D, over here we said D is a copy of A. So it gets its own separate value, not a reference back to A. Okay, so does that make sense? The difference between what happened here and why B changes when A changes versus over here D did not change when A changed. Is that okay? All right. Okay, now we can have methods, all right? So methods are going to be functions, but this time the functions belong to the objects. So here I'm going to say we're going to define a reference class called account. As far as the fields and values that it contains, or the values that it keeps track of, we have the balance, which is a numeric value. And then we're going to give it methods. Methods is a list of functions. So here we have two functions. We've got the withdraw function and we've got the deposit function. What you'll notice is that the withdraw function uses the superassignment. Okay, it says withdraw is a function of x, and what withdraw does is it takes the balance and it subtracts x and it updates the balance. And deposit does the same thing. It takes the balance and it adds x and updates the balance. Okay, but here we're using superassignment, and we actually want to use superassignment. This is one of the few times where I say superassignment is a good thing. Okay, because if we think about a reference class object, we want to think about the reference class object as an environment inside R, right? You have your global environment, and within your global environment, you have the environment created by the reference class object. This environment for account, so if I create A as an account here, this reference class environment will have the value balance, and also it will contain the function withdraw and the function deposit. Those are the three things that exist inside this mini environment inside the global environment. So inside this environment, if I want to use the withdraw function to update balance, when I execute withdraw, what happens is it creates its own execution environment, right? But execution environments only, the values inside an execution environment only exist during the execution of the function and don't actually adjust anything outside of it. So if I want the execution environment to update the balance inside this reference class environment, I have to say use the super assignment. So I'm going to say super assignment balance, and then it will update the balance inside this reference class environment. Okay, so it's important that the value that we use here to update using the super assignment is one of the fields that exist. If over here I said withdraw as a function of x, and we're going to do y, is we're going to do balance minus x super assignment to y, it's going to look for y in the higher scope outside of the execution environment. It's not going to find y, and it's going to keep climbing up the scopes until it reaches the global environment or something, and that's going to cause problems. But as long as you're using names that are within the list of fields, then when you run the method inside the reference class, so you've got balance inside here, you've got method withdraw, and when you execute withdraw, it creates an execution environment, but it updates the balance inside here, then we're good. Okay, it's not changing things in the global environment, it's just changing things within that reference class environment. Does that make sense? So that we want to use super assignment when we define methods inside a reference class. So here we've got withdraw as a function of x. We're going to say balance super assignment balance minus x. Okay, so let's take a look at this. We're going to create a new instance of account with the balance 100. Okay, and when we do this, A is going to be its own kind of reference class environment. So let's see. So here we have this. So we're defining what the reference class is. And now I have A, and we can see A as an environment, right? So it says reference class object of class account field balance. And I don't know, can I view A? No, I can't. All right, but we can execute the method deposit. Okay, so I say $$ deposit, and it runs the method here. It's going to deposit 100, and so if I ask what is the balance in A, the balance in A is now 200. Okay, so I didn't have to do $$ balance is $$ balance plus 100 or something like that. Let's say I do B is equal to A here. All right, so what the balance in B is 200, and if I do B $ deposit 150, B balance is 350. What is the balance in A? Is also 350, because again, B references A. B is not a copy of A, B is a reference to A. If I wanted a copy, I'd have to do D is a $$ copy, okay? And I can say D balance here, and I can do D withdraw 100, okay? The balance in D is 250, and if I ask what's the balance in A, it's 350, and what's the balance in B, it's 350, okay? So B and A, B is linked to A as a reference, not, it's not its own separate thing here. Okay, let's, we'll keep looking on here, and we can define other reference classes to contain another reference class object. So here, I'm going to create a no overdraft reference class. A no overdraft reference class is basically a special version of the account reference class. So we're going to say no overdraft contains account. So what that means is if we look at account, which contains balance and the methods withdraw and deposit, no overdraft will contain those same things: balance, withdraw, and deposit. But here, I'm going to define a new withdraw method. Okay, and here we've got withdraw is a function where it does a check to see if the amount you're withdrawing is more than the money that you have. And if it is, it's going to kick back an error that says you don't have enough money. Otherwise, update the balance like you normally would. Okay, and so you can kind of think of this, and this might not be 100% accurate, but you can kind of think of the no overdraft as something that exists inside the regular account. And therefore, when you ask for the balance no overdraft, it's going to start here and it says, oh, you know what, I don't see balance in here, so it climbs the scope and it finds the balance in account. But when you ask for the method withdraw, it will find the withdraw method inside no overdraft, and it will not climb the scope. Whereas if you ask for the method deposit, it doesn't find deposit inside no overdraft, so it climbs to account and it finds the deposit method there. Okay, so here I'm going to create an account for John, and it's going to be no overdraft with a balance of 100. So if we use deposit 50, because no overdraft contains account, it's going to inherit this method. We didn't define the deposit method here, but it's defined in the account reference class, so we can do it, and John's account now has a balance of 150. But if I call withdraw on 200, it's going to use the method right here, and it's going to say, you know what, the balance is 150, you're trying to withdraw 200, so it's going to kick back an error. So here it says error in account and executing this function, and it says not enough money. Okay, so these are, this is how it runs here. All reference classes eventually inherit from the environment reference class, which is contains methods like copy and new and things like that. So so that I didn't have to define a method called copy, but it exists as soon as I create a reference class, because they all inherit from the environment reference class here. And of course, you can always look up help and things like this. Okay, with reference class objects, they are S4 objects. And you can always say, you know, are they reference class because they inherit from reference class, right? And as far as method dispatch goes, it just makes sense because the methods themselves belong to the objects. So it's very different from the S3 or S4 system where the methods belong to the generic functions. Here the methods belong to the objects. So when you say, you know, the only way you execute the withdraw function is by calling account John $withdraw, right? If you wanted to, you could say because no overdraft inherits from account, you could say I want to execute the function withdraw using the account method rather than the one that it normally does, okay? And this will use the parent method. But other than that, I mean, this is something you don't really have to worry about because the reference class things generally behave the way you expect them to because the methods themselves belong to the objects, and you can only execute methods that are defined for the for that object there. Okay, so that wraps it up for today, and we'll we'll see you guys on Friday, and I hope the rest of your tic-tac-toe assignment goes well.